Hello everybody, I hope you're having a great day. Today we're going to talk about the Pythagorean Theorem. The Pythagorean Theorem is familiar to most math students, and when they hear the Pythagorean Theorem, they usually quickly jump and say that means a squared plus b squared is equal to c squared. And so many students, when they just hear the Pythagorean Theorem, they think this is exactly what it is. A squared plus b squared equals c squared. And while that's a huge part of it, that itself is not the Pythagorean Theorem. And so I want to make sure we understand what it is and what it's not, okay? And so what we're going to do, let's take a look at Pythagorean Theorem. Well, I have the Pythagorean Theorem states that the sides, or the length of the sides, that the sides of any right triangle. The Pythagorean Theorem states that the sides of any right triangle fit into this equation. Okay, and then that kind of leaves a little gap of, well, what's the equation? And the equation, of course, is a squared plus b squared equals c squared. Okay, so the lengths of any three sides, of any of the sides of any right triangle, so the Pythagorean Theorem states that the sides of any right triangle fit into this equation. There's one last little catch, where c is the hypotenuse. Okay, so like in this picture right here, I have A is one of the legs, B is one of the legs, and C is the hypotenuse. You can always identify the hypotenuse because it's opposite of the right angle. It's the one side that doesn't touch the right angle, whereas the other two sides, the legs, that make up the right angle. And so those are the A and the B, and the C is always the longest side, and it's always opposite of the right angle. So that's the hypotenuse. Okay, now this can be used, this information is true. If you take the lengths of the sides of any right triangle, it'll always fit in to this equation. But we can use this information to find unknown sides of a right triangle. Let me give you an example. In this one right here, I've been given the length of the legs, but I don't have the length of the hypotenuse. It's simply x. So I could write, well, if I know that a squared plus b squared is equal to c squared, well, then that would have to mean that 6 squared plus 7 squared would have to equal x squared. And 6 squared is 36 and 7 squared is 49, and that would have to equal x squared when I add them up. And 36 and 49 add up to be 85. So like I said, that's x squared. So what in the world is x? And some people freak out because they go, well, wait a minute, 85 doesn't have a square root. Well, sure it does. It's just not a nice clean number that we think of, but the square root of it is the square root of it. So x is the square root of 85. This is a great classroom answer. Now, if you needed to give me a real world answer, you should be able to realize that 85 is in between 81 and 100. And why are these numbers important? Well, 81 is 9 squared and 100 is 10 squared. So if 85 is somewhere in between these two, then the square root of 85 is somewhere in between these two. And so you could say that the square root of 85 is somewhere in between 9 and 10. Now you could argue whether it's closer to 9 or closer to 10, but most of that's just guessing. So for this case, I'd say, well, square root of 85. And if I had to go to the store to buy some lumber and I needed to be square root of 85 feet long, I don't think the people at the store or me are going to know exactly what that is. So it'd be good to say, well, I need something between 9 and 10 feet. All right, let's look at the second problem. This other one is a little bit different situation. Here we're given the hypotenuse, but we're missing one of the sides. Well, it still comes down to that true statement of a squared plus b squared is equal to c squared. So I could say 5 squared plus y squared is equal to 10 squared. Now, you don't always put the number you're looking for. You don't always fill that in for c squared. That's not how this goes. C is always predestined to be the side opposite of the right angle. And so that has to be the c. So this is how I would set it up. 5 squared plus y squared equals 10 squared. Well, 5 squared is 25 plus y squared, which I don't know, equals 10 squared, which is 100. So I would subtract the 25 from both sides, and I'd get that y squared is equal to 75, so therefore y is equal to the square root of 75. Now, how big is the square root of 75? Well, that number right there is in between 64 and 81. I picked those because 64 is 8 squared, 81 is 9 squared, so therefore square root of 75 is somewhere in between 8 and 9. But square root of 75 is a great classroom answer. All right, now that you've seen me work those two, what I'd like you to do right now is I'd like you to look at these three. I want you to pause the video and try to see if you can work out all three of these. And I'll work them out in just a minute when you're ready. Okay, hopefully that gave you enough time, or you paused the video and you've taken care of it. So for this first one, really easy. 8 squared plus 9 squared equals x squared. 8 squared is 64, 9 squared is 81, equals x squared. If you add those two up, what do you get? 145. And that's so close to 12 squared, but it isn't. So therefore, x is equal to the square root of 145, which is in between 12 and 13. 12 squared is 144. So you go, man, it's just a little bit bigger than 12. That's what it would have to be. All right, let's look for this next one. I would know that 4 squared plus y squared is equal to 8 squared. And 4 squared is 16 plus y squared, I don't know what that is, equals 8 squared, which is 64. Subtract the 16 from both sides, and you get y squared is equal to 48, because 64 minus 16 is 48. So therefore, y is equal to the square root of 48. Now, some of you might be familiar with simplifying radicals. And what it means to simplify as a radical is it means if I take this idea of square root of 48 and go, that's the same thing as the square root of 3 times 16, because that's what 48 is. 3 times 16 gives you 48. And you ask yourself, do you know the square root of either of these? I know the square root of 16. I know the square root of 16 is 4. So therefore, that number can actually come out. And you could rewrite this as 4 times the square root of 3, because the square root of 16 is 4. So that can come out and show up as that 4 right here. And the square root of 3 has to stay, because I don't know the square root of 3. Okay? So therefore, in this case, the square root of 48 is the same thing as 4 times the square root of 3. And either answer is acceptable. It's just that this answer right here is called simplest radical form. And so we really like that answer. Okay, and now let's take a look at this last one. For z, I can say that z squared plus 7 squared is equal to 12 squared. So I have no idea what z is. 7 squared is 49. 12 squared is 144. If I subtract 49 from both sides, that would give me 95. So therefore, z is equal to the square root of 95. All right. Again, notice that the hypotenuse is always the one that's by itself. Whatever side is opposite that right angle is always going to be the one in place of the c, or c squared. All right. Now let's take this a step further, okay? I want you to imagine we had a box. And what I've tried to do here is I've tried to draw this box 3 times. And with it, I've tried to draw a red line. That red line is supposed to be touching the front top left corner and then the back bottom right corner. Oops, not what I meant to do. All right? And so my question is, how long would that red line have to be? Now, if you look, you go, wait a minute. If I use 4 and 6, that's not the hypotenuse right here. That doesn't make sense. And if I use 4 and 5, it's not the hypotenuse right here. And so we can kind of be a little confused with how to do this. So I want to show you. Okay, there's 2 ways of looking at it. That's why we've got 2 boxes left. One way is looking at that triangle like it's a right triangle that's laying down. I don't know if you can see that, but I'm saying, okay, that triangle is laying down inside that box. Not all the way flat, but its bottom is right here. Its backside is right here, and its hypotenuse reaches there, okay? And for me to do that, I would need to know the length of this side right here. Well, the length of that side, well, that's the hypotenuse of this right triangle. And so that one I can figure out. I know that this side is 4. I know that this side is 6. So I can say that 4 squared plus 6 squared is equal to, and I'll call it c squared. Well, 4 squared is 16. 6 squared is 36. Is equal to c squared. So therefore, c squared, if I add up 16 and 36, I get 52. So c is equal to the square root of 52. That's how long this blue side is right here, okay? Now, but that doesn't give me the red one yet. But it tells me that that is square root of 52. But then I can look and go, okay, so this triangle that's laying down inside there, it has the bottom is right here. Now I know the back side is right here. And I know the back side is square root of 52. So how long is this side right here? Well, that side is 5, because the depth of every one of these sides is 5. So if this side is 5, then I could figure out what this other side is, and I'll call that other side x. And so I would know that square root of 52 squared, which sounds kind of ugly, but actually is really nice, plus 5 squared is equal to x squared. Well, square root of 52 squared, you just get rid of the radical, and it just becomes 52. 5 squared is 25, is equal to x squared. Add these two up, and I get 77. And if 77 is x squared, then x is the square root of 77. That's what this is right here, square root of 77. And if someone asks you how big that is, you go, well, it's somewhere between 8 and 9, because 8 squared is 64, and 9 squared is 81. It's probably closer to 9. All right? So the length of that side is square root of 77, which is somewhere between 8 and 9. Now, I said there were two ways of looking at this, and so that was one of them. So I've got this other box here to show you another way of looking at this. The other way of looking at this would be, what if we thought about that triangle in the sense of it was slicing the box diagonally, okay? And so it was actually standing up, running from the front corner edge to the back corner edge, okay? And in this triangle, this is now the height of the right triangle I'm looking for, but I need the base, this side right here. And that base is actually the hypotenuse of this right triangle, okay? Half of the bottom of that box. Well, I know that this side right here is 6, and I know the depth of the box is 5, so therefore I could say, well, that would mean that 6 squared plus 5 squared is equal to whatever that side is. I'm going to call it c squared. So that gives me 36 plus 25 is equal to c squared. So therefore c squared is equal to 36 and 25 is 61. So c is square root of 61. Now you might be nervous because these two answers don't match. But of course they don't match because it's not the same thing. We're looking at different parts. And so then, in fact, I'll get rid of all this for a second. So then I take that, I know that side right there is now square root of 61, and I know the height. The height is 4, okay? So I can say that 4 squared plus the square root of 61 squared is equal to this x squared that I'm looking for. So 4 squared is 16. Square root of 61 squared is just 61 is equal to x squared. So if I add those up, I get 77 is x squared, so therefore x is the square root of 77. And look at that. I get the same answer because math is true. And so now what I want you to do is I want you to try this. I've drawn 2 more boxes, and I don't care which way you do it, if the triangle's laying down or if the triangle's standing up, but I want you to try to find the length of the red line that runs from the top corner to the back corner. But I have not yet drawn that red line. So let's see here. We'll try to do that real quick. I'm saying, can you figure out the length of that line right there? And I know in case that makes it a little bit tough for your eyes to kind of track with, because this part is covering it. There we go. Okay. So you can pause the video right here, and I'll work these out in just a second. All right. Hopefully you got those worked out, and you saw that this was really simple. Now, I don't care if you have this triangle standing up or laying down or whatever. It doesn't matter. So for this one, I'm going to go ahead and say, well, let's pretend it was laying down a little bit. And so here's that right angle. The triangle is kind of laying this way. I hope that makes sense. And so I know that the base is 7, and I know that the other side right here that I need to find, the height of that triangle, is the hypotenuse of this front side. It's the hypotenuse of this right triangle. And so I know that the height of this thing is 8. It's back here. So I say 6 squared plus 8 squared is equal to c squared, which would mean that 36 plus 64 is equal to c squared. Well, 36 and 64 is 100. And if that's c squared, well, then good news, c is 10. Well, that's nice. This side is 10. And then I would know, okay, the base is 7. The height of that one is 10. So now I can say 7 squared plus 10 squared is equal to this unknown that I'm looking for. So 7 squared is 49. 10 squared is 100. It's equal to x squared. Add those up. We get that x squared must be 149, so therefore x is equal to the square root of 149. Pretty simple. All right, let's move that off to the side a little bit. Okay, and now for this next one. Okay, for this one, I'll do the triangle as if it was standing up. So I cut it this way. Picture that right angle right here. And we're saying that triangle is kind of standing up and it's slicing through that box from the front edge to the back edge. Okay? And so at this point, I know the height of the triangle I'm looking for is 4, but I don't know the base. The base is actually the hypotenuse of this triangle, half of the bottom. And I know the depth is 6, so I can say that 9 squared plus 6 squared is equal to c squared. That would give me 81 plus 36 is equal to c squared. Well, 81 and 36, unfortunately, doesn't come out very nice. It's 117. So therefore, c is the square root of 117. But it doesn't matter if I get a number that's not clean, because now I know the base. The base is square root of 117. And then the height is 4. So 4 squared plus the square root of 117 squared is equal to that unknown I'm looking for, squared. Well, 4 squared is 16. Square root of 117 squared is 117 is equal to x squared. And when I add those up, I get that x squared is equal to 133. So therefore, x is equal to the square root of 133. All right, hopefully those are the same answers that you got, because those are the right answers. All right, we're on the home stretch. We talked about what is the area of a triangle. Well, the area of a triangle, in case you didn't know, is always 1/2 the base times the height. And so here the question is, what is the area of this triangle right here? Well, good news is we have the base. Bad news is we don't have the height. Okay? Now, clearly this is an isosceles triangle because both of these sides are 8. And I don't know if you remember, but if you bisect that vertex angle of an isosceles triangle, then that always perpendicularly bisects the base, which means that this piece is the same length as this piece, and that this would have to be a right angle. So this side would be 3, and this side would be 3. And I could figure out the height, because now, whether you see it or not, I've got a right triangle whose base is 3, whose hypotenuse is 8, and the height is some unknown. So I would know that 3 squared plus whatever the height is squared is equal to 8 squared. So therefore 9 plus 8 squared is equal to 64. Subtract the 9 from both sides, and 8 squared is equal to, not 80, 55. So therefore the height is the square root of 55. And even though that's ugly and doesn't come out clean, it still can be plugged into this formula. It's no different, okay? And so I would say that the area is equal to 1/2. What's the base? Well, I got to go back to the base of the whole triangle, not just this one. The base is 6 times what's the height? Square root of 55. So in answer, 1/2 of 6 is 3. So I get 3 times the square root of 55. That's that easy. And if someone said, well, about how big is that? Well, you'd have to think. Square root of 55 is somewhere in between 7 and 8, because it's in between 49. It would have to be in between the square root of 49 and square root of 64. So then if I multiply 3 times 7, I would get 21. And 8 times 7 is 24. So therefore, this number right here has got to be somewhere in between 21 and 44. There we go. All right, so that would be my real world answer. But this is a completely acceptable classroom answer. All right, now your turn. I want you to go ahead and try to find the area of this isosceles triangle. You can pause the video right now. Okay, let's see what you got. First thing I'm going to do is I'm going to cut this down the middle. That makes this side 6. So I know that 6 squared plus the height squared is equal to 7 squared. So therefore 36 plus whatever that height is squared is equal to 49. Subtract, and the height squared has got to be equal to 13. So the height is equal to the square root of 13. Area of a triangle is 1/2 the base times the height. So you get 1/2. What's the base of the whole triangle? 12. And the height is square root of 13. So 1/2 of 12 is 6 times the square root of 13. Square root of 13 itself is somewhere in between 3 and 4. And so therefore 6 times 3 is 18. And 6 times 4 is 24. That this answer is somewhere in between those. Okay, so here's my classroom answer. Here's my real world. All right, the last thing that we're going to take a look at is this. There's something called the converse of the Pythagorean theorem. Now, if we know that in a Pythagorean theorem, in any right triangle, the 3 sides always fit into that formula. The question is, what if you stumble upon some triangle? can you use that formula to figure out what kind of triangle it is? And you can. So for instance, I might look at this one and say, well, if this were a right triangle, this would have to be the hypotenuse because it's the longest side. So you go ahead and plug it in. 3 squared plus 4 squared is equal to 5 squared. Well, 3 squared is 9, and 4 squared is 16, and 5 squared is 25, and 9 plus 16 is 25. So in fact, 25 is equal to 25. What does that mean? That means that this has got to be a right triangle because the sides fit into this formula. Now, though, if this side had happened to not be 5, but it was 6, well, then I would have 3 squared plus 4 squared is equal to 6 squared. And that would be 9, and 16 is equal to 36, but that would mean 25 is equal to 36, and that's not true. Now, and so I would know for a fact that that's not a right triangle, but I bet I could also figure out what kind of triangle it is. So I want you to think about this. Here's 3 situations. This first one's a right triangle, and we're saying, man, this could be where a squared plus b squared does in fact equal c squared, just like we had. 3 squared plus 4 squared equaled 5 squared. But in this new case, we had 3 squared plus 4 squared equaled 6 squared. And it didn't actually equal that because we had 25 is not equal to 36. This number is too big, which would mean that that side, this c, is too big, which would mean it would actually come all the way to like here, okay? And that would push back this b value. So let me try to see if I can draw this a little bit better. That would push back this b to back here. So it would open this up all the way to here. And so this, what is now a right angle, wouldn't be a right angle, but in fact, it would be obtuse. Okay? When your hypotenuse does not fit into the formula because it's too big, your triangle must be obtuse. But also, if I had 6, 7, and 8, so that I thought that 6 squared plus 7 squared is equal to 8 squared, which would be 36 and 49 equal to 64. Well, 36 and 49, that's 85. 64 is too small. Well, what would happen if we took C and we shrunk it? Well, now all of a sudden B would be somewhere here and C would be down here. So this angle would have closed in, okay, because C was too short. It couldn't reach. So if C was too short, if this number is too small, meaning your hypotenuse is too small, then it must be acute. And so here's a really easy thing to do. If it plugs into that formula and it works, then it's right. If it's just right, then it's a right triangle. If you plug it into the formula and the hypotenuse is too large, it's obtuse. And if you plug it into that formula and the hypotenuse is too small, then it is acute. And it's just like that. I hope this has helped you with the Pythagorean theorem and the converse of. Have a great day.